Hi everybody, this is Mr. Molikash. Today we're going to talk about some topics that you'll encounter in week 4 in the course. The first is absolute value equations and sometimes inequalities, and then later we'll talk for a little bit about graphs of equations and finding x and y intercepts. Okay, so let's get started. So with absolute value equations, we need to understand what the words absolute value mean. The absolute value of a number means how far it is away from 0 on the number line. So if you're looking at a number line, here's 0, you have to ask yourself which numbers are a distance of 5 units away from 0 on the number line. And there are two options for that, right? You could have gone to the right 5 and be at positive 5 on the number line, or you could have gone 5 units to the left and be at negative 5. So for that reason, the solution to this equation is either x equals negative 5 or x equals positive 5. There are two solutions. So what happens if we don't have an equation? What happens if we have an inequality? So in that case, our distance has to either be greater than a certain distance from 0 or less than. So first, we'll see what happens if the distance is less than 5 units away from 0. So if we can only move 5 units away from 0, there is a limit to how far we can walk away from 0 or move away from 0 on the number line. So we can be 1 unit away from 0. 1 is a distance that's less than 5. We can be 2 units or 3 or 4 or even 4.5 or 4.9, but we have to be strictly less than 5 units away from 0. So I'm going to put an open dot here that indicates that I can't be equal to 5 on this number line, but I can be less than 5. And of course we can walk the distance the other direction if we're walking on the number line. So our numbers are at negative 5 and 5 for the limits of the interval. But the solution to this would be that x is between 5 and negative 5. So one way to write this is to say that x is both less than 5 and x is greater than negative 5. Now this is a little bit long to write out, so mathematicians and people in the textbook have written this in a much more compact way. You can say that x is less than 5 and at the same time switch this around and say, well, if x is greater than negative 5, then negative 5 must be less than x. Notice that both of the inequalities are going the same way. So we can write all of this by saying negative 5 is less than x and x is also less than 5. And this is the most compact way of writing. Okay? You can also write this in what's called interval notation. In interval notation, you'll be talking about that in your textbook and in ALEKS. And this is an open interval between negative 5 and 5. Now the reason I'm using parentheses is because these dots are open. If they had been closed, we'd be putting brackets there. So let's discuss what would happen if there was an equal sign here. If I had put that there, how would that change the problem? Well, that would change the problem by saying, okay, now I can be equal to 5 units away from 0. And all these inequalities would have equal signs included in them. And so would these. And then these parentheses would now have brackets. So always use brackets when you're including the number. Always use parentheses when you're not including the number. Okay. Now let's see what happens if the distance is greater than 5 units away from 0. So here we are. Let's say this is greater than, and this time I'll say strictly greater than like I did it first the last time. So we have our number line again with 0 in the middle. The basic idea of absolute value is the distance from 0. So we want to be more than 5 units away from 0. So this means that we have to get further than 5 units away from 0. So our graph would look something like this, and I'll use red now. I want to put an open dot here and be greater than 5 units away from 0. So I could say 6, 7, 8, 9, even 5.1, and every number after that. Similarly, I can do this in the other direction. My distance from 0 could be more than 5 units by going to the left of 0 in the negative numbers on the number line. So we have an open dot there, or open circle rather, and then all numbers before negative 5. So how would we say this? How would we write the solution to this inequality? There's two ways to write it. You can say that x is less than negative 5 or x is greater than 5. You can't be in both places at the same time, so don't use the word and. Another thing you can do, though, is you can use a set of disjoint intervals. So in interval notation, you'd say, of course, the negatively infinite numbers on the left, positively infinite numbers on the right. Sorry, I just moved the camera a little bit. So what you'd say is from negative infinity to negative 5. I always use parenthesis when dealing with infinity because infinity is not a number. You can't equal infinity or negative infinity. And then, of course, here I'm going to use a parenthesis because, like we said before, there's an open dot. Similarly, here we're going to use a parenthesis with 5 and then go on to infinity and beyond. Just kidding. Buzz Lightyear to the rescue. Now, the way to say or with intervals is to call this a union. A union is a collection of things. If anything is in the union, it's in either one of the intervals, it's in the union. So we take these two together and put them in a collection, and we call that the union. So, okay, again, we can write this. This is called set builder notation in the textbook. Or an interval notation, if it asks for that, then we want to write this. These are two different ways to write the solution for this inequality. Okay, now let's look at some more complicated equations or inequalities. So first one I'd want to look at, we'll do this. We'll say the absolute value of 2x plus 1 equals 5. So with equals, remember this amount that's on the inside could be in one of two locations. It can be sitting at 5 or at negative 5. So we immediately split this into two equations. One where the number inside could have been negative 5 or positioned at negative 5, or we could do positive 5. And then these are pretty easy to solve, so I'll just do these really quickly. And then divide by 2, and we get x is negative 3. And then over here, and I'm sorry if I'm moving the camera again, but yeah, we get x equals 2. So these are the two solutions that would make this equation true. Okay, now what happens to this problem if it's an inequality? Well, as we said before, if there's a less than sign here, okay, then the x's are going to be between these two numbers. So in that case, what would happen is you'd see that, and I'll leave these numbers down here because we'll see them again, but your 2x plus 1 would be between negative 5 and 5. So you could solve this three-sided inequality, if you will, by subtracting 1 from all three sides, and then dividing everything by 2. And then you could say, well, 2 is on the right side, negative 3 is on the left side, and x is between these numbers. So again, this is set builder notation. In interval notation, you'd use parentheses and say the open interval from, sorry, that should be positive, negative 3 to positive 2, not including the endpoints. Okay, and of course, if this were greater than, then we'd be using the other intervals on the number line from negative infinity to negative 3, union from 2 to infinity. So rewind this video and look at the example for that if you need some help there. Okay, the last thing very quickly we're going to look at are how graphs of different equations can have x and y intercepts. So you'll see this on your written homework in week 4. So let's just give you an equation let's say 2x squared plus y equals 16. So whenever you're finding the x-intercept, okay, the x-intercept is when the y-coordinate is 0. So we want some x-coordinate when y is 0. For the y-intercept, we want the opposite thing to happen. We want the x-coordinate to be 0, and we're going to be stuck on the y-axis. So what we need to do for x-intercepts is put 0 in for y and solve for x. So the first thing I'll do over here is do that. So we'll have this problem first. So what we'll do is take 2x squared plus, now y is 0. So that just turns into 2x squared equals 16. Now we'll divide by 2 to get x squared equals 8, and then have to take the square root of both sides. And x is going to be plus or minus the square root of 8. And I trust that you'll know how to reduce the radical like you did in Math 171. So that would be plus or minus 2 square root 2 for the radical, simplified radical answer. So what do we know about these two numbers? One's positive, one's negative, and then these are the x-intercepts for this, the graph of this equation. Okay, for the y-intercept, we could do a similar process. For the y-intercept, all we need to do is, again, we'll do this problem now. So what we'll do is we'll put 0 in for x now and solve for y. So this is going to be now 2 times 0 squared plus y equals 16. And then we'll do the order of operations. So 0 times itself is 0. And 0 times 2 is 0. And 0 added to both sides or subtracted from both sides still gives you 16 on the right side. So this means that the y-intercept is 16. Okay, so in summary now, what we can say from all of the work that we have here is that the x-intercepts are 2 square root 2, 0, negative 2 square root 2, 0, and the y-intercept is 0, 16. So this gives you a little bit of information about the graph of this equation. If you were to solve this for y, this would be a parabola, that kind of thing. So yeah, and again, if you have trouble simplifying radicals, let me know, send me an email, or collaborate with people in the collaboration discussion board. I can give you some helpful hints on how to simplify radicals, and there's a couple of different ways you can do that, but just kind of contact me privately and we can work on that together, or ask your classmates. So that's a little bit of what you'll see in week 4. Please keep up with your ALEKS and make sure that you're not getting behind. Please communicate with me, ask me questions if you need help. So again, JCSMAT at johnstoncc.edu. So hope you have a great day. Thanks so much.